So I want to take a look at another useful shape in this two-dimensional shapes library. This is the ellipse. An ellipse is sort of like a circle, except you get to specify 2 radii instead of 1. The larger of the two is called the semi-major axis, and the smaller of the two is called the semi-minor axis. And in our case, we're going to make the semi-major axis go along the x-axis, and the semi-minor axis go along the y-axis. That doesn't really matter because we can rotate this thing any way we want to anyway. Since this is a 2D shape, we have to extrude it to actually be able to see it. So we're going to specify this path here, moving 0.1 units along the z-axis. And then here we use the extrusion function. We specify the path to move along, and we specify the ellipse shape. And for reasons that'll become clear in just a minute, we are going to set the opacity to 0.5 so that it's 50% transparent. So here we've got our ellipse. Again, it's got a semi-major axis of 1, so the distance from the center up to here is going to be 1, and the distance from the center out to this farthest point is going to be 3. So basically every point in between those two along the ellipse is some distance from the center between 1 and 3, because this is the minimum width and this is the maximum width. Again, here's our extrusion distance here, 0.1. That's not terribly important for the ellipse. We're mostly going to focus on this face right here. What I would like to do is be able to visualize the semi-major axis and the semi-minor axis. So let's add in a curve object to represent each of those. So let's go with semi-major axis. And let's see here, I want a curve. I need it to start in the center. So the center of this object is just going to be ell.pos. It's like the sphere or the box. Its position is the location of its central point. And then we'll say I need to go to another point, ell.pos. Let's go over to the right. So we're going to go in the positive x direction. And we need to go a distance of the semi-major axis W here. And that should give me my semi-major axis. There it is. Starts in the center, goes out to the edge here. If you wanted to extend this all the way to this other edge, that would just be the major axis, not the semi-major axis. Next step, let's make the semi-minor axis going up this way. So I'm just going to copy and paste this guy and change major into minor. And then I can go up in the y direction instead and change this to my h value. And we'll hit Control 2. Cool, so now I've got the semi-major axis and the semi-minor axis. And this is pretty important because in physics, an ellipse is what you get when you've got a stable orbit for the gravitational force. So if you're working with a simulation of a planet going around a sun, you could use this ellipse shape to kind of overlay on the orbit and then use these curve objects to get the semi-major axis and the semi-minor axis, just so you can visualize the orbit a little bit better. I suppose you could also animate these things and use it to demonstrate Kepler's third law. That would be pretty cool. And one of the things you need to calculate with an ellipse is its eccentricity. So to end this, I'd like to set up a function where we can calculate the eccentricity of this ellipse. So we would put in the semi-major axis and the semi-minor axis. And to calculate the eccentricity, you have to take the square root of 1 minus the semi-major axis. So semi-major axis squared divided by the semi-minor axis squared. And I'm writing a little bit differently here because suppose somebody got these flipped around and they put them in the wrong order. We wouldn't want that to happen. So what we are going to do as a failsafe here is we're going to call the semi-major axis the maximum of the two, W and H, and we're going to call the semi-minor axis the minimum of the two. And it actually even doesn't matter whether they put in the semi-major axis and semi-minor axis or the major axis and minor axis, because that extra factor of 2 is going to cancel out here anyway. So we can just return this guy. I guess I should have put return there before. Oh well. And so what we can do is print the eccentricity of our W and H. And I need to put parentheses around this. Oh, actually, you know what? Speaking of getting things backwards, I got this backwards. This is the minor, this is the major, because obviously you want to take 1 minus a smaller number over a larger number to avoid getting an imaginary eccentricity. Let's see. Okay, so we get an eccentricity of 0.94. So this is a pretty important number because a circle is an ellipse with an eccentricity of 0, because a circle is an ellipse where the semi-minor axis equals the semi-major axis. And so when you have an ellipse that's close to 0, you've got an ellipse that's, when you have an eccentricity that's close to 0, you have an ellipse that's close to a circle. But the squishier you make your ellipse, the closer to 1 this number becomes. And again, we can use this code to help visualize that. So suppose I exaggerate this even more. Let's make this a semi-major axis of 10. There's a very squished ellipse, and we get an eccentricity very close to 1. If we go in the other direction and make this close to a circle, let's suppose these only differ by 1%, then I get a pretty close to a circle here, and I get pretty close to 0 here for the eccentricity, which is pretty neat. One very last thing we'll take a look at. There's a similar object that I just want to show you is the ellipsoid. And this is a 3D object that you can, that's basically an ellipse rotated around. You could technically, I guess, get this by doing an extrusion, but it's just easier to reference the ellipsoid. You get to specify a position for this thing. Let's place this away from our ellipse. So let's give it 0, 2, 0 for our position. And then you just give it a length, width, and height. So I could give it a length. Let's actually make this thing longest in the z-axis. So let's make the length kind of narrow, a little bit taller in the y direction. Let's give it a height of maybe 0.3, and then let's make its width in the z direction. Let's make that a 1. So we make it point out in the z direction. Let's hit Control 2. And so there you have it. There is our ellipsoid up at the top. So you can use this as like a data marker or a little pointer or something like that. I think it's pretty cool. If you make all those size elements equal, you'll get a sphere, just like this ellipse becomes a circle. This thing can become a sphere. So I think that's pretty neat. Those are some neat visuals. So I hope those are useful to you. Thank you so much for watching. I will see you next time. Bye-bye.